Hello everybody, AOG Gaming here. This is not a gaming video, so if you guys want to, not watch this video, it's fine. This video is going to be about, well, as you know the title, dark matter, dark energy, what it is, what I think it is, because I've been thinking about this a lot. No, that comes as a surprise, but yeah, so I'm going to start with this. In the universe, so far as we have observed, there's balancing acts that happen, whether it be chaos and order, whether it be gravitational systems balancing out. It just is an apparent thing in nature. There's also particles and antiparticles. There's just this symmetry that seems to exist in nature that is a defining rule of our existence, our reality. So, one thing that I was thinking about is dark energy is basically what the void is made out of, dark matter, whatever you want to call it. So the void itself, what would that be? Well, that would be technically no particles. We're not talking about quantum level because technically quantum interactions can be seen as differently than just, well, they called it quantum foam or whatever, but they can be seen as different than what we can see, like from this level, because quantum interactions rely on time differently, and quantum gravity is different than gravity at the large scales, just like in the universe itself. So, one thing that I'm thinking about how the vacuum works, basically where the universe resides in, it's affected by gravity from, the Big Bang, whenever those gravitational waves end and extend to, and also all of the matter inside that is collecting and creating its own gravitational fields and waves. Now, what I'm thinking how dark matter, dark energy works is that it actually keeps, like, our galaxy together. It keeps galaxies together. It basically clumps everything up together. And I was thinking of why that is because, the physics of how objects move through space, through a vacuum, like how we have observed, the objects would just, in a galaxy, would just disperse, especially in our galaxy, because everything spins faster or towards you get to the center, I believe, and it's slower towards the outside, which is very interesting. Um, so I was thinking about gravity and how it didn't exist in the very early universe when everything was very compact to an infinite point right before the Big Bang. So I was thinking about how gravity doesn't naturally exist in the void, in what dark matter, dark energy, whatever you could call it, could be. Like, specifically, where there is no gravitational fields, no matter that you can physically see whatsoever, just empty space. So I'm thinking about this and I was realizing something. What if dark energy, dark matter, is resisting gravity itself because it's not supposed to exist within the universe naturally? Because gravity is created through matter clumping up, and you know everything has gravity in the void. As long as it's matter, light is affected by gravity as well. So I was thinking about this, and I'm thinking about how dark matter, dark energy actually resists changes to gravity. And this is why the universe, or more specifically, not the universe, galaxies and superclusters stay together because they create their own fields of gravity wherever that gravity field ends, wherever the edge of the gravitational influence is where the dark matter basically is concentrated on, is what I'm thinking of. So why this happens is because most of that dark matter, there's still dark matter, within our galaxies, our superclusters, in between, there's still vacuum in space, but gravity is present there. So, what if all that gravity is just all the dark matter, sorry, is being slightly displaced by the gravity, and this is what causes sorry, not universes, galaxies. I'm thinking of like a million different things here. Galaxies and superclusters stay together because dark matter itself is resisting the changes to gravity because it didn't naturally exist before the Big Bang, basically. But also, it doesn't naturally want to be affected by gravity. We don't know this because, you know, gravity, sorry, dark matter itself, dark energy, we haven't found it. We have no proof if it's real. We just know that it exists. There is matter out there that makes up space, which is, the void itself, the vacuum itself. Now, quantum foam exists. It's basically subatomic particles coming in and out of existence on a very small, very, very, like beyond quarks and leptons and bosons and whatever you want to call them. Um, Quantum, I'm just going to look it up real quick. Foam. Yeah, it's a top trending. So, theoretical quantum fluctuation of space-time on a very small scales due to quantum mechanics. So, I believe that in the void, this quantum foam is much easier to measure. So, first, what we as humans would need to do in order to get a full grasp on quantum foam and also dark energy, dark gravity, because the way we're measuring it now is in a vacuum, but we're within a gravitational field, within a supercluster, megacluster, and it affects our readings because we have to account for gravity, but we don't know what the waves at the beginning of the Big Bang were. We don't know all these. We can't basically measure all of this gravity and account for it because we don't know what the gravitational waves were like at the beginning of the Big Bang. Like, yeah, we have clues about it, we have theories about it, and we're getting close. But in order to accurately calculate dark energy and this or quantum foam, I guess that's what they call it, the emergent process, um, we need to measure the void itself when it's not being influenced by gravity, which is kind of impossible considering that the Big Bang itself released all these gravitational waves and they are present throughout space and time. But I do believe that at least will narrow down to just the single or, the gravitational waves that were present when the Big Bang exploded. So what we need to do is basically get out of the super mega or, super cluster, mega cluster, um, and go to basically deep empty space and measure quantum foam, dark energy, and, well, I guess quantum gravity if you want, but at that point we're digressing. Of course, that's gonna take us centuries, millenniums, like it's millenniums. It's really gonna take forever because we're not there yet. Well, we're getting close to warp drives, but still working theories. So anyway, I was thinking that the reason why sorry, let me explain it better. The reason why I'm thinking that dark matter, dark energy affects space time like this and why it resists gravity is because there's this little thing called the great attractor that everyone knows, right? Space, as far as we can see it so far, as far as we have observed, is slowly going to one point in space and time. And this is all part of the super and mega cluster. It's all going towards one direction. And we don't know why. So I was thinking that maybe the reason why this happens is because dark energy itself, dark matter, is resisting that change of space time, which is gravity, because it affects space and time. and it is slowly pushing it towards this great attractor. Now, you can say that I'm wrong because it's attracting, not pushing. However, we don't know exactly how um, dark matter, dark energy works. We just know it exists. So there are actions in nature that look like attraction when really they are repulsion in the opposite sense. I don't know if that makes sense. I don't have a specific example on hand, but you can definitely find things in nature that are like that. So it's just very interesting. And I think the reason this happens is because, um, well, because everything wants to be at the lowest state of energy possible, and gravity itself, like the universe itself, wants to be at the lowest energy level possible. It wants to be stable, and gravity warps space and time. So it's in an unnatural state, and gravity itself is a type of energy. So, I mean, as you can obviously tell, because light itself can gain energy from black holes and speed up, or objects themselves can do that. So it's just interesting to me. And that was my theory on how dark matter, dark energy itself can affect space time itself. I don't know, a lot about this, but it's just things that I've read, things that I've seen, and just stuff that I've been following on. Um, there's a lot of famous scientists out there, a lot of famous posts. But yeah, so the Great Attractor. Let me just see real quick. Tour. The Great Attractor. I spelled that wrong. Is a purported gravitational attraction in intergalactic space and the apparent central gravitational point of the Laniakea supercluster, the one that we're in. Um, so basically, all of space time is flowing towards this point, and there's some pretty cool pictures of it. Um, but yeah, oh wait, mm, yeah, technically, will the great attractor defeat dark energy? That's an interesting theory. I'm just looking at different stuff online right now, but it's very interesting. So that was just one of my theories. Um, that it's all going towards this one point because that is maybe towards the origin of the Big Bang. I'm not gonna, say anything about that because I could be probably am 100% wrong. Um, but yeah, it's just interesting that everything is going towards this one point in space, but it's all being kept together. So maybe light matter is what I'm calling it, the opposite of dark matter. So that would be basically anything that is not at the smallest quantum level possible, which would be quantum foam, is light matter. So it exists, well, there's still dark matter in between. So basically, it affects space time by creating gravity, by clumping together, and in turn, this is being resisted by the universe, space time itself, because it wants to be at the lowest state of energy possible, like I explained, and it'll just push it towards each other, basically, all together. And this is what I think the great attractor is. I'm probably 100% wrong, but just a theory, just sharing my ideas to the scientific community, even though, I'm just a small YouTube channel and there's probably nobody who's going to see this, maybe 4 people, because I do get some views on these types of videos. So that was just my theory on it. And why I say that is because we have not been able to find an explanation for gravity on the quantum level. The reason I think this is because the quantum particles themselves are, like quantum foam itself, works differently with gravity because it still exists in a vacuum. So maybe the smallest particles, I know a lot of the scientific community is probably going to be mad at me, but I don't think that quantum gravity exists on that small level. I know everyone says that gravity is a fundamental rule of the universe, which it is. I'm not saying it's not, but I think that we're looking at gravity different. I think gravity really exists when there is significant amount of matter to the point where it warps space and time. But I do still think that quantum gravity exists on some level because I think about it like this: there are different energy levels and fields of energy in the universe that exist within our universe. And all of these fields affect different types of particles, and they react differently with different types of matter. So maybe there are types of matter, however small, because it seems that gravity does affect everything, even at insanely large scales. There's a really small units of matter don't that aren't affected by gravity and don't actually produce gravity because they work more with time itself rather than space. The reason I say that is because space and time are linked together in some way that we still haven't found out how, but maybe it's to do with quantum foam itself, which is why particles come in and out of existence. Maybe that is particles that aren't affected by gravity, so they aren't affected by normal time, and simply they are going through the process of existing and non existing cycle, basically before they're created and after they were created. And time is just much faster on the quantum foam level. Just a theory. Um, but it could explain why things come in and out of existence at such a small scale, and yet they seem to have very small effects on large large clumps of matter, space-time. It doesn't have a very great effect, but it still is interconnected by everything because that is the time part of our universe. It is connected by these very, very, very small subatomic particles that we see, and maybe that's where tachyons are. Quantum foam is where tachyons are. So the tachyon, it's not a particle that technically exists so far as we have observed, but maybe on the quantum foam level, it's affected by time particles because the particles that exist, the matter that exists within quantum foam, is so small that time itself affects it like an actual particle rather than a wave. I know, mind blowing, right? Just think about that for a little bit. Um, so yeah, it's just really interesting to think about. And I was just pondering this for a while because it makes sense with dark matter because space time itself is being warped, and space and time itself would want to go back to its original state, which would be just a void. Um, and the reason all matter itself, well, because I have to explain all of this because otherwise I'm just like, it sounds like I'm going off on a tangent, but I'm really trying to like base it on something to show you guys my thought process because it is a thing. Um, I mean, there's also dark flow, but we're not even going to talk about that. Yeah, I mean, everything flowing in a common direction. Yep, of the great attractor. So it's just interesting. So what I was saying before is that space time itself is worked by the gravity, and quantum foam itself exists within the vacuum, and it's resisting these changes because gravity works differently on the quantum foam level. This quantum foam level, I guess we can call it the subquantum level or the quantum realm, I guess, if you want to get a, sci-fi. Um, but yeah, it's just interesting to think about because quantum foam exists, yet we have no real way of explaining why particles come in and out of existence. And maybe this is to do with gravitational fields themselves. The gravitational field that existed on the Big Bang warped the entirety of the universe to the point where particles can come in and out of existence, which is why they exist. And maybe outside of the observable universe, maybe outside of the Great Wall or whatever they call it, the bubble surrounding our universe. Maybe outside of this, or maybe there's not even a wall. Maybe it's just an infinite void of that we can't tell because of how light works in the universe. And just very interesting how that works. I'm gonna stop there because otherwise I'm gonna keep going on tangents. But yeah, just my little theory on how dark matter works and why universes stay together and why dark matter seems to be present around galaxies and superclusters. Anyway, thank you guys for watching. As always, this is AOG Gaming. If you're enjoying the content, please like and subscribe. It really shows your support. It helps me out, keeps you up to date with my content. 70 subscribers and going strong last time I checked. So you guys are amazing. Keep going. And yeah, that's all I have for this video. Um, tell me what you guys think in the comments because I would really like to know. It's a really interesting way of thinking. It's probably wrong, but yeah, it just seems too coincidental that we see all of this symmetry in the universe and gravity itself is in unbalance in the universe because it's warping space and time, and space and time wants to be at its lowest level of energy, which is not being warped at all. So it just seems coincidental and somehow eerie, not eerie, somehow strange that gravity exists, but there is nothing to counteract the gravity so far as we have found. So maybe that's what dark energy is. It resists changes to gravitational energy. And if enough of it builds up, it can keep galaxies and superclusters together. And it keeps matter itself. Well, I said light matter, but it keeps matter itself. And that's why together, which is why it's all going towards one place, the great attractor. Anyway, thank you guys for watching. As always, that was my last thoughts, and I will see you guys later.